In this module, Enhancing Security Practices with Crossplane, we focus on securing crossplane environments. You will learn how to authenticate with cloud providers securely and implement best security practices. This course is designed to equip you with the knowledge required to safeguard your cloud resources using Crossplane. This overview sets the foundation for the essential security measures you need to be aware of when working with Crossplane and its providers. Through this module, you will gain insights on how to protect your infrastructure and ensure that security policies are properly enforced, mitigating any potential risks stemming from misconfigurations or unauthorized access. In this module, we're focusing on the importance of security in crossplane environments. Security is a key aspect that ensures your cloud resources are protected from unauthorized access. Following robust security practices not only helps in safeguarding data, but also ensures compliance with corporate security policies. It is essential to mitigate risks that come from potential misconfigurations, which could expose sensitive information or disrupt services. By enhancing your security posture, you create a resilient system that adheres to best practices and regulatory requirements. Let's talk about securing cross-plane authentication, specifically in the context of AWS. There are several methods available to ensure the authentication process is secure when using cross-plane with AWS. First, AWS access keys are commonly used. These keys are a pair of access credentials that include an access key ID and a secret access key. Another method is assume role with web identity. This allows your application to assume an IAM role using a web identity token, which can be useful in federated environments. Lastly, IAM roles for service accounts, RSA, enable your Kubernetes workloads to assume IAM roles and obtain temporary AWS credentials. This approach is particularly powerful as it assigns roles directly to service accounts, removing the need to handle long-term credentials. By understanding and utilizing these methods, you ensure robust authentication for your cross-plane deployments on AWS. Let's continue discussing authentication methods for cross-plane providers. In this slide, we'll focus on Azure. With Azure, there are two primary ways to authenticate: system-assigned managed identity and user-assigned managed identity. A system-assigned managed identity is created for a specific resource, such as a virtual machine, and its lifecycle is tied to that resource. When you delete the resource, the identity is also deleted. On the other hand, a user-assigned managed identity is created independently of any resources and can be associated with multiple resources. This identity and its permissions remain intact, even if individual resources are removed. These approaches help ensure that your Azure resources can securely communicate with each other and access the necessary services without needing to manage sensitive credentials manually. On this slide, we continue exploring different authentication methods, this time focusing on Google Cloud Platform, GCP. There are three primary methods to manage identities and authenticate services. 1. OAuth 2.0 access tokens. These tokens are used to authenticate and authorize API requests. They provide a way for applications to access resources on behalf of a user while still keeping the user's credentials secure. 2. Service account impersonation. This method enables a service account to act on behalf of another service account. It can be particularly useful in scenarios where access needs to be delegated across different services or projects within GCP. 3. Workload identity. This is a recommended method for securely accessing resources from GKE Google Kubernetes Engine clusters. It provides a way for workloads running on GKE to authenticate using Google's identity platform without requiring the use of long-lived service account keys. Understanding these methods will help you securely manage and authenticate access to your GCP resources. In this slide, we're going through the steps to set up IRSA for Crossplane in an EKS cluster, leveraging AWS's Identity and Access Management IAM with OpenID Connect, OIDC. Firstly, you need to create an OIDC provider to establish a trust between your EKS cluster and the IAM roles. This is done using the EKSCTL utils associate IAM OIDC provider -cluster mycluster approve command. Next, you define a service account for Crossplane with IAM roles. This can be achieved using the following set of commands: SHESTL create IAM service account Tash name Crossplane am space cluster my cluster clutch my policy RN ARWS IM AWS policy Amazon S3 read-only access approve. This service account will now have access to the Amazon S3 read-only policy, enabling secure access to S3 storage within your EKS environment using URSA. On this slide, we focus on how to handle authentication using Azure Managed Identity. Specifically, we're looking at System-Assigned Managed Identity, which simplifies authentication management by automatically attaching credentials to Crossplane pods within your AKS cluster. This automatic handling means you don't have to manually manage service account credentials, streamlining secure access to Azure resources. It ensures that your Crossplane pods can seamlessly interact with Azure services under the desired identity without requiring additional setup configurations. In this slide, we'll discuss an authentication example for GCP workload identity and how to set it up for Crossplane in GKE. The first step involves enabling workload identity. This is done using the gcloud command as shown, specifying your cluster and the workload pool. This links your GKE cluster to your GCP project. Next, we need to annotate the Kubernetes service account. Using the kubectl annotate command, you specify the namespace and service account for Crossplane. This command binds the Kubernetes service account to your GCP service account, allowing your workloads running in GKE to authenticate as the GCP service account. These steps authenticate your Crossplane pods to interact with GCP services securely and efficiently. This slide focuses on the security audits of Crossplane, specifically highlighting the audit conducted by Audits in July 2023. The audit report identified a total of 16 issues, categorized into 7 low severity, 8 medium severity, and 1 high severity issue. This thorough examination helps ensure that Crossplane remains secure and reliable. The findings provide essential insights into areas that need attention to enhance the overall security posture of Crossplane. In this slide, we're focusing on the high-severity issue identified in the Audits audit report, CVE 2023-38495. The issue centers around image tampering without validation, which poses a significant threat. The recommended fix for this vulnerability is to implement content hash validation. This ensures that any packages you use have not been tampered with. To verify a package, you can use the command sh-256sum package.tgz grep expected hash. This command generates the SHA-256 hash for the package and confirms it matches the expected hash, ensuring the integrity and authenticity of the package. Implementing this validation step is essential for maintaining a secure environment. Now that we've broken down the high-severity issue and discussed the importance of validating content with a hashing mechanism, let's move on to the structured approach for fixing vulnerabilities. The first step is to review the audit report thoroughly. This ensures you understand all potential vulnerabilities within your system. Next, apply patches to address these vulnerabilities directly, patching known issues to mitigate risks as swiftly as possible. Finally, monitor for new vulnerabilities continuously. This ongoing vigilance helps maintain security and quickly adapt to newly discovered threats. By following these steps, review, patch, and monitor, you'll enhance your system's resilience against vulnerabilities. Now that we've covered the steps to fixing vulnerabilities, let's move on to some practical application tips. Implementing best practices is essential for maintaining a secure environment. One effective method is tagging resources. This helps in organizing and managing your assets more efficiently. Regular audits are another key practice. They help ensure that your security measures are up to date. Automated resource tagging can also play a significant role. It ensures compliance with your security policies. Additionally, it helps you identify and rectify any deviation in real time. These tips will help you maintain a secure and compliant environment, reducing the likelihood of vulnerabilities being exploited. When working with multi-tenant environments, securing your cloud resources is paramount. Let's focus on a few key strategies. First, segregation of access is essential. This means ensuring that different tenants have access only to the resources they are permitted to interact with. Next, namespace isolation plays a critical role in maintaining security boundaries. Isolated namespaces ensure tenants operate in their dedicated spaces without interfering with each other. Lastly, role-based access controls, or RBAC, further tighten security by assigning specific permissions based on user roles. This minimizes the risk of unauthorized access and elevates security management to a more granular level. In summary, employing these multi-tenancy security measures will help you safeguard your cloud environments while maintaining tenant isolation and access control. In this slide, we will be discussing the importance of external secret stores in managing secure credentials within your deployment ecosystem. Using an external secrets management system like HashiCorp Vault is recommended for handling sensitive information. This approach not only enhances security, but also streamlines the process of accessing secrets across various environments. Integration with systems such as HashiCorp Vault ensures that your credentials are stored securely and accessed only when necessary, maintaining the integrity of your deployment pipelines. Let's consider a real-world scenario: secure connectivity. The primary challenge here is securely connecting application deployments to cloud databases. To address this issue, we can leverage Crossplane resources and its secure connectivity features. Specifically, we can utilize AKS, EKS, and GKE to establish secure connections, ensuring that deployments communicate with cloud databases without compromising security. In this scenario example, we will focus on securely connecting your AWS EKS clusters with RDS databases. The objective here is to ensure that our connections are as secure as possible while using Crossplane to manage our network components. Specifically, we'll be leveraging Crossplane to set up virtual private clouds, VPCs, subnets, and security groups. These components are essential for isolating and securing your networks, preventing unauthorized access to your databases. By configuring Crossplane to manage these resources, we streamline the process and enforce consistency across your infrastructure. This approach not only simplifies management, but also strengthens your security posture. In this slide, we're looking at a practical example of how to create security groups in Crossplane for securing connections, particularly for resources like RDS. The command shown here is a kubectl apply f command that creates a security group through Crossplane. The YAML manifest specifies details for the security group. We define the API version, kind, and metadata to indicate it is a security group. In the spec section, we configure the security group to have a descriptive name and provide details such as the VPC ID and ingress rules. In this instance, we open port 5432 for PostgreSQL traffic over TCP protocol from any source IP. This approach integrates with Crossplane to manage your network security groups efficiently within your Kubernetes environments, ensuring secure communication channels for your AWS resources. In this concluding section, let's summarize the key points we've covered regarding secure authentication practices, applying audit findings, and best practices for secure connectivity. Firstly, ensuring secure authentication is fundamental. We've demonstrated using Crossplane to create and manage security groups, which are vital for controlling access and maintaining the security of your resources. Secondly, understanding and applying audit findings is essential for identifying vulnerabilities and ensuring compliance with security policies. Regular audits help you to spot and rectify any potential issues. Lastly, we discussed best practices for secure connectivity. This includes configuring security groups with precise rules to restrict access and minimize potential threats. By following these practices, you can significantly enhance the security posture of your deployments. In this slide, we are presenting our final thoughts and recommendations for implementing robust security measures. It's important to conduct regular audits and updates to ensure your system remains secure and compliant with best practices. Utilizing secure, automated tagging mechanisms can help in managing resources effectively and maintaining security control. Also, implement multi-tenancy and role-based access control, RBAC, to restrict access and ensure that users only have the permissions necessary for their roles. These strategies strengthen your overall security posture and help protect your systems and data. In this section, we focus on actionable steps you can take moving forward. It's essential to keep up to date with the latest information and best practices around Crossplane. I recommend exploring the Crossplane documentation for detailed insights into the platform's capabilities and configuration guidelines. Additionally, refer to security audit reports to understand any vulnerabilities and the measures taken to mitigate them. These documents provide valuable lessons learned from real-world scenarios. Lastly, make sure to consult guides on setting up Crossplane securely. These guides offer specific instructions to ensure that you implement robust security settings from the onset. Let's now discuss some valuable references and additional resources that can further enhance your understanding and secure implementation of Crossplane. Firstly, the official Crossplane documentation is your go-to resource for everything related to installation, configuration, and day-to-day management. You can access it at h/docs.crossplane.io/latest/. For broader security practices within cloud-native environments, the CNCF Security Best Practices provide comprehensive guidelines, and they can be found at cncf.io/security. When it comes to security tools, OSS Fuzz, available at github.com. Google OSS-Fuzz offers continuous fuzzing for open-source software to discover vulnerabilities proactively. Additionally, HashiCorp Vault, which can be accessed at h2ww.vaultproject.io/, is an excellent tool for managing secrets and protecting sensitive data. Lastly, to understand the current security posture of Crossplane, you can refer to the Ada Logic Security Audit Report, which is available at the provided link. Use these resources to ensure you are following best practices and keeping your Crossplane environment secure.